Okay. So this is just a quick review from what we graphed last time. If you need to find absolute value of x, you need to do this on your own. You're going to go to math. You're going to arrow over to number, and it should be choice number 1. So math, arrow over, choice number 1, and it should be there in y equals. Our x button, anytime we put the x in, I'm going to click it. It turns red when I click it. And go ahead, from there you can hit graph. Okay, and then we're going to go ahead and hit graph. If your graph is like not centered, just a reminder, if your graph is not centered, you can hit zoom and then 6, and that'll fix the centering. If you get an error while you're doing this, let me know so I can help you. I might already know an error before it happens, so just listen, because I know some places people are going to get an error. Okay, so you see how you're sitting with 2 people. Have them help you, and if they can't, then I'll help you. But I'm making the video right now, so I prefer you guys help each other first. He needs to know what to type in. Okay, we are going to go back to y equals, and we're going to go to y2. Here, I'm about to do absolute value of x again. So if you didn't get it the first time, I'm doing it again right now. So go to y2. We're going to put a second equation in there. We're going to go absolute value. So math, which just turned red. So you can see when I click a button, it turns red. Then we go over to num, N-U-M, number. And then we choose 1. And then the X button is right next to alpha. And that's how we get our absolute value of X. But we're going to make this one different. We're going to give this a transformation. We're going to add a number. And you can add whatever number you want. I'm going to add a 4. Just feel like it. So I'm putting plus 4. We did this yesterday. We should know or have it written down, or not yesterday, it was 2 days ago for us, sorry. We should know or like have it written down what this does, but I'm going to go ahead and look at it again. We're going to hit graph. And now my red one, my Y2, it's higher up. It starts higher up. How much higher up does it start? 4. I wonder if that's because I put plus 4. Coincidence? No, it's not. Okay, so we had our notes, and you were supposed to write down if we are on the outside of a function, what's that going to do? And you, in your own words, you're going to say like it moves it up k units, because that 4 was just that one specific example, but you might have put plus 2. You might have put plus 9. Whatever you added, that's how many units it goes up. It goes up that many. Then we did f of x. We did a function take away a number. Now, we probably did absolute value. I'm going to change the function because what I need you to know is what the different functions look like. And that changing the function does not change what this k value does. It's the same for every function. So now, instead of absolute value of x, clear all of that stuff out. Go back to y equals, clear it all out. Clear, clear, clear. Let's try x squared. So I'm going to hit the x button first. It's red right now. Then the x squared button is on the first column. It's like next to a comma. That's the x squared button, so that puts the squared up there for you. So that's our parent function. We looked at it, what it looks like last time. If you hit graph, there it is. It's a U shape. Go back. Okay. If yours has an error, will you double check that you have x to a 2, but nothing else there? yours look like that? Hit graph. Who got it? Oh, wait. All right. Yeah, that's right. Okay, so now what we're going to do is let's do x squared again. Oops, I clicked the wrong thing. Let's do x squared again. Now, if I add 4 to this one, if I add 4 and I hit graph, it does the exact same thing the plus 4 did on the other one. It's just you're starting with a different starting graph. So when I did the plus 4 for the absolute value, the V started up 4. I did plus 4 for squared, the U shape started up 4. So it does the same thing. What happens if you do minus 4 or minus any number? What happens? When we do subtraction, it goes down by that amount. Okay? So if we are on the outside of our function, it's going to move the graph down that many units. Whatever number it's adding or subtracting. That's why I have a K there, because it could be any. It could be 100 if you want, but we won't see it on our graph. All right? After that, then we did inside. Inside is next, and inside looks different. So I'll do one of the insides with this graph, with this parent function, I mean. So go to your Y2 and clear out the Y2, but leave your Y1. We're still going to start with that U shape. To put it on the inside, I have to have an inside, so I'm going to do a parenthesis. I'm going to put the X inside the parenthesis, plus, and then just any number I feel like putting in there. Close the parenthesis, and then do the square. So I can see that this is on the inside because the squared is around everything. That's what the parentheses are doing, is making me square that 4 along with the X in there. Okay, so everything's being squared. This is on the inside. We did this last time. You hopefully wrote down some notes, but we're doing it again. When I hit graph, this one went to the left 4 units. This moved to the left 4 units. Move to the left 4 units, right? So if you didn't have something written down like moves it to the left, that's what we want to write now. Okay, so it's going to move to left, and then this time I used an H, units. The H just stands for whatever number is sitting there, and the H and the K are actually really important later, but we don't know that yet, so that's why I'm using those specific letters. Okay, so when it's on the inside and it's adding, we kind of do what's opposite of common sense. Like when I see plus, I'm thinking positive, but it's actually going left, which is negative. So what if we change it to subtraction? You know what? Let's change the parent function so we can see that it does not matter what the parent function is, that these rules still apply. So I'm starting Y1 again. I went to Y1, I cleared it out, and I'm going to do X to the 3rd power. So to get the caret, to get the up there, the little exponent, you have to hit the caret button, which is red right now. It's underneath clear. Yeah, clear it. So if you don't know where the caret button is, it's red right now. And then after that, you just type in a 3. And then once you hit graph, you should see it. X and then caret. Okay, so we've got this kind of fun squiggly graph. Let's go to Y equals. We're going to do something on the inside. So to do inside, I need to open a parenthesis, X, and we're doing minus this time, right? Minus 4, close the parenthesis, squared. So we're doing parenthesis, X minus 4, close the parenthesis, squared. Oh, I'm sorry, cubed. You're right. That was me messing up, forgetting what we were doing. Make it a cubed. There, make it a cubed. Because we want the same function. We want them both to be cubic. Go ahead and hit graph. I just haven't done it yet, just in case somebody's still looking at mine. So it's on the inside. Did you get it? Copy? So when you hit graph, this one, it was on the inside. It was minus, but it actually went to the positive direction. This one kind of goes opposite of what you think. The inside, the two inside ones, they do opposite of what like common sense would tell you. All right, so hopefully you have something written down. I'm writing it myself right now. Oops, wrong thing. Writing it myself right now. Inside, that's going to move to the right. H units. Maybe I will add to this stuff that it's kind of opposite of common sense. Like these two are kind of opposite of common sense. Those two. The Y value ones, the ones that went up and down, those follow their signs perfectly. The positive went up, the negative went down. This one was like opposite. I might add in some more words. Let's see, these were left and right. I mean, I have it left. Nah, I'm not going to add this in because I already have it written there. Okay. All right, so now we're going to start the ones we didn't get to last time, which were negative signs. Okay. I want you to know that a negative sign is not just a negative sign, but that negative sign is the same thing as a -1 being multiplied by whatever is inside here. Well, I'm telling you that you can write it down if you want, but that's not my description. I just don't have space on my paper. I could write it on the board, but then the video wouldn't save it if I'm, on the board, not on this. But like if I do -1 times by, let's say we're going to do x squared. Let's say we're going to do x squared, okay? If I do -1 times by x squared and actually multiply those together, Jackson, do you know what -1 times by x squared is? Yeah, it's going to be -x squared. So this is what you're going to see. You'll see this. But we need to know that that means -1 multiplied by x squared. Okay? It's not just some random negative floating in the air. That's a multiplication thing. All right? Now, when you type it in, you don't have to write -1 times by. You can write -x squared. So let's go to y equals clear, clear. And I'm going to do x squared again as my original parent function, x squared. Okay, so I did x squared as y1. Check the people next to you. Make sure that they are following. X squared. Okay, now we're going to go down, and there is a different, to y2, there is a different button. And this is where you're going to get an error if you don't follow along. There's a different button for negative than there is for subtraction. So make sure you do the negative x squared, not subtraction. Negative x squared. Once you do that, you can hit graph. Mine's up longer so people can catch up. When you hit graph, check the people at your table. Do you all three have the same graphs? Do the two of you have the same graphs? Show each other. Do we all have the same graphs? If you don't have the graph yet, help them. I'm gonna hit graph. Okay? So what does it look like happened? It is a reflection. Where? Over the x-axis? Or you could say up and down. This one would be down, but if it started down, it would be up. Yeah. Okay. So in your own words, we're going to write that the negative on the outside is going to be reflection, up and down, or a reflection. What did I say? the x-axis over the x-axis. Okay, so I'm erasing this work I had before because I need space to write. It's taking forever though. This is why my videos are so long, because I have to like do that. All right, so we're going to reflect. We're reflecting over the x-axis, or maybe you said reflect up and down. Okay, something like that. So is that the same for other parent functions? Because like I said, it should be the same. Let's see. Let's go back to y equals. Can we change it to absolute value? Let's change it back to absolute value. Math, number, absolute value, x, arrow down, math, number, absolute value. Oh, I forgot to put my negative sign. Clear. Negative, math, number, absolute value, x. So that's what I'm typing in there. Let's see if it does the same thing, because Miss Criswell said it was going to do the same thing. Let's prove her right or wrong. If we do absolute value of x and we do negative absolute value of x, does that do that same thing? Show your graphs to the people you're sitting with. Mine's not up there yet. If they need help, help them. Are your people looking at your graphs? You guys are good? Okay, so it should look like mine. And yes, it is a reflection up and down. All right. Let's change this to the other negative. So the next negative, the last thing we have on these notes is inside. So we're going to put a negative on the inside this time. We're going to put a negative on the inside. All right. Again, it's multiplying by -1. But and you don't have to write this, you can just look for a second. If I take absolute value and I do -1 multiplied by x, it's going to be absolute value -x. So like it's there, but that's because I multiplied by -1. All right. So I'm going to go ahead and do that. So this time I'm doing absolute value first. Then I do negative sign. Then I do x. That's how I get it on the inside of the absolute value bars. Once you've gotten that, hit graph, check with the people around you. If you have a black and white calculator at this moment, it might be difficult to see what's happening. So I will graph mine momentarily, but I want to make sure everybody has the opportunity to graph theirs first. So hit graph. Okay, I'm going to graph mine. If you have a black and white, watch mine. My first graph is blue. My second one is red. So if you have a black and white calculator, watch mine. Here we go. 3, 2, 1. Blue, red. What happened? They're exactly the same. Okay? So when I put a negative on the inside, I can say, oh, it's exactly the same. Or maybe there's a reason why this one's the same. Because it's absolute value. And what happens if we absolute value a negative number? And what happens if I absolute value a positive number? It's also positive. They are the same. But this negative thing isn't always it's not always the same. Sometimes it changes things. Okay? So I'm going to give you a different parent function to start with. Did we do x cubed yet? We did, right? X to the third. So if we're putting it on the inside, you got to put parenthesis, x, negative x, sorry. Close your parenthesis, then do you to the third. So make sure you have it in parentheses to do it on the inside. So once you have that, go ahead and hit graph. Are those two different? Or are they exactly the same? They're different, aren't they? Okay, so I'm going to graph mine. How are they different? Reflected what? Over the y-axis? Okay. At the C, do negative sign, x, close parenthesis, then keep.
All right, good afternoon, Firebirds. Pardon the interruption.
Enjoy the announcements, but we're not done.
But it is time now for us to reveal the results for the 2023.
While they're revealing,
homecoming
I'm going to
course.
graph square root x.
Your
Second.
sophomore representatives are Olivia Dawson, Madeline Kirkmeyer, Josie Buesler. Your junior representative is Charlie Bechet, Katie Cozile, and Izzy Wilbur. And then your senior representatives, Nyla Escobar, Sophia Hayes, Will Jackson, Josue Moda, and Brennan Rimmy. Congratulations.
Okay.
Congratulations.
So we're
indeed.
doing
We will
square
be
root,
calling
and
those
you have to do
individuals
second,
down on Monday
and then
to
the
give
x
them
squared
their
button, which is
information
red right
packet
now,
for planning
and then click
purposes.
X.
Until then, congratulations. Thank you to all of our Firebirds who participated.
You
in
can hit
voting
graph to see
this
what it
year.
looks like. Just make sure
We
your
look
graph
forward
works.
to a very fun-filled Spirit Week next week. And
Okay, so I hit graph, and this is what it looks
celebration
like.
with the football game next week. And then
So now we're going to do
on
square
Saturday.
root.
We now return you to
Negative.
the regular scheduled, wonderful academic classroom learning experience. Go Firebirds.
What? It's giving you an error. Did you do a subtraction? Oh, it shouldn't. If it's giving you an error, you might have done subtraction instead of negative sign. You're good?
Yeah, I just
Okay.
thought, like, usually with square root, you can't square root.
Oh, I see what you're saying. So we don't know what x is. So what if x was -4? And then I had a negative in front of that. Okay. So that's a good thing to bring up. When I hit graph, what happened is this is a reflection left or right. This is a reflection in the y-axis. Okay. So this last negative thing, the last multiply by -1, that's a reflect in the y-axis. And then that you could also write as reflect. Here, let's erase this. That's from a different class. That's reflect left or right. Okay. We're going to try some examples. Well, real fast. When you're looking at all of these, every single thing out here that says outside, you should look at the direction the ones that say outside go. Is that too dark to see through? The ones that say outside, the ones that say inside, the ones that say inside up here. What do you guys think? They have anything in common? Anything on the outside's up and down. Anything on the inside is left and right. Every single time. Okay? So this is how our assignment's going to work. One of the pages I gave you doesn't have a lot on it. Looks like this. Okay? We're going to look at that one. All right. Your assignment actually only kind of looks like the bottom 3 graphs with an equation. There's some other stuff here, but this stuff is what you're going to have to kind of think through. You won't have to write down in your assignment these first 3 things we're about to write down. Okay? I want you to know you won't have to write that in your assignment, but I'm going to write it for notes because you have to think through this. So the very first thing that we have is question A. F of x equals negative absolute value of x. So what family does that belong to? I said the word already. Absolute value. This is the absolute value. right? My thing is too thick. Here we go. Now, the parent function for absolute value is just f of x equals absolute value of x. Has nothing been done to it. No multiplication, no extra numbers, no adding, subtracting, nothing being done to it. It's just that. And then on our paper that we took notes on, what does it mean when we have a negative sign outside of those bars, outside of the absolute value? What? Oh, yeah, because you came in later. So what's that mean if we have it on the outside? Well, the negative number, the negative one means a reflection no matter what. So if you don't have it memorized yet, you look at your notes. And it reflects over that x-axis. Yeah, it reflects in that x-axis. You could say, it reflects up and down. So what you're going to do on your graph, so you're thinking these things that I just wrote down, you don't have to write those down. This is the thought process you're going through. What you actually write down for your assignment is you first graph the parent function. So we graph our original v. And you're going to make that dashed so that when I look at your paper, I know what's what. So the first thing you're going to do is make a dashed v. Then you're going to do the new one, which we just talked about. It's going to reflect over that x-axis. Here's the x-axis. So we flip it over, and it looks like that. We do that without a calculator. Now you have a calculator so you can check your answer, but we're doing it without a calculator because when we take a quiz on this, it will be no graphing calculator. You have to know these things. So the next one is x squared plus 5. If I see an x squared in it, does anybody have that written down in front of them? What's that one called? Nope. That was like b to the x. This one's x to a second. Yeah. It's quadratic. Yeah. Quadratic. All right, so you got those words written down. The parent function is f of x equals x squared. We saw that today. We saw it today. What's a plus 5 do? Notice the plus 5 is not being squared. So this is on the outside. This plus 5 is on the outside. Up 5, right. I'll talk about vocabulary next week, but I'm writing it down even though we're not talking about the word. But yeah, it's going to go up 5. So on our sketch, doesn't have to be super accurate, but on our sketch, you're going to dash that U shape. And then you're going to go 1, 2, 3, 4, 5, and you're going to make a solid. Oh, he left. Oh, anybody know what number he is?
Well, no, did he switch it for a calculator?
Oh, does he have my calculator? Oh, Jesus. I don't know which one's his. Tell me which one's not his. Oh, no, there's his face. Okay. And then the third one. So this one right here is also squared. So this one is also quadratic. They're both quadratic. So it's still f of x equals x squared. But what does the minus 2 do if it's on the inside? This one does opposite of what we'd think. So since it's minus 2, we're actually going to move it to the right. Translate right 2 units. So again, you're just thinking through those words. What you're showing me is that you know that it's, sorry, I'm trying to do this too quick. You know that it is a U shape. And then you can show me it moving to the right 2, and then draw your U again. Can we look at the homework real fast? Because I want to show you one or two that's maybe a little bit trickier than these in the notes. I'm just going to draw them because I don't have the homework open, but you guys have it in front of you. Let's look at number 6. So it tells you f of x equals negative absolute value x minus 3. So we start and we say that's absolute value. What's absolute value look like? Absolute value looks like a v. Dash it, because this is the parent function. Now, I have two things happening. So one of them is this negative sign. Is this negative sign on the inside or the outside? Okay. So that means it's up and down. This minus 3 is on the inside. That means it's left and right. So let's be more specific. The outside negative sign, what does that do? Flips it down. But what's this minus 3 do? It goes to the right 3. Okay, that one's opposite. So we're going to be to the right 3, but it's going to open down. So I combined both things. So I moved it to the right 3 and I made it flip. Both. Yes. No, because you have to know what x is first, and then you have to take away 3 from that number. So if I had like 10 minus 3, it would be the absolute value of 7. So that doesn't make the 3 positive. So your assignment is to find these. I will have an answer key posted. It's not yet. You can check them with your graphing calculator, but you should not be getting them with your graphing calculator. You can check them with the graphing calculator, but you cannot get the original with the graphing calculator. You need to learn what these do. Use your notes. You can go ahead and put it right over there. That's fine.